Q8919. What is the ratio of turns between the primary coil winding and the secondary coil winding of a transformer designed to triple its input voltage? A. The primary will have 1/3 as many turns as its secondary. B. The primary will have twice as many turns as its secondary. C. The primary will have 3 times as many turns as its secondary. The correct answer is A. In a transformer with a 3-to-1 step-up ratio, the secondary winding will indeed have 3 times as many turns as the primary winding. This step-up ratio indicates that the voltage in the secondary winding will be 3 times higher than the voltage in the primary winding. The increased number of turns in the secondary winding allows for the transformation and amplification of voltage, enabling the transformer to step up the voltage level from the primary to the secondary side. This relationship between the turns and the step-up ratio is a fundamental principle in transformer operation and plays a crucial role in voltage transformation and power distribution systems. Q8920. In an AC circuit with no phase lead or lag, which is true? A. Real power is 0. B. Real power is greater than apparent power. C. Real power equals apparent power. The correct answer is C. Real power equals apparent power. This is the correct option. In an AC circuit with no phase lead or lag, where the voltage and current waveforms are in phase, the power factor is unity, 1. In this case, the real power is equal to the apparent power. The power factor is a measure of how effectively the circuit utilizes the apparent power, with a value of 1 indicating a perfect match between real power and apparent power. Q8921. How are generators rated? A. Watts at rated voltage. B. Amperes at rated voltage. C. The impedance at rated voltage. The correct answer is B. Generators are typically rated based on the maximum current they can deliver at their rated voltage. This rating indicates the generator's capacity to produce electrical current under specific operating conditions. The rated current specifies the maximum load that the generator can handle while maintaining its rated voltage output. By providing this information, generator ratings help users determine the suitability of a generator for their intended applications, ensuring that the generator can meet the required electrical demands without exceeding its current capacity. It is important to consider the rated current along with other specifications when selecting a generator to ensure efficient and safe operation. Q8922. How is a shunt-wound DC generator connected? A. One field is shunted across the other. B. Both fields are shunted across the armature. C. The field and armature are shunted with a capacitor. The correct answer is B. In a shunt-wound DC generator, the field winding is connected in parallel with the armature winding. This means that the field current flows through its own separate path, independent of the armature current. The armature winding is responsible for generating the output voltage, while the field winding creates the magnetic field necessary for the generator's operation. By connecting both field windings in parallel across the armature, the shunt-wound generator ensures that the field current remains relatively constant regardless of the load connected to the generator. This allows the generator to maintain a stable output voltage. The shunt connection also provides good self-regulation, meaning that the generator can maintain a fairly constant voltage output even when the load on the generator changes. Q8923. The poles of a generator are laminated to A. Reduce flux losses. B. Increase flux concentration. C. Reduce eddy current losses. The correct answer is C. In order to mitigate eddy current losses, the pole shoes of a generator are commonly constructed using laminated soft iron. This choice of material helps minimize the formation of eddy currents, which can lead to power losses and heat generation within the generator. Eddy currents are induced circulating currents that occur in conductive materials when exposed to changing magnetic fields. By employing laminated soft iron for the pole shoes, the generator design effectively reduces the flow of eddy currents, resulting in lower power losses and improved overall efficiency. This approach allows the generator to optimize its performance by minimizing energy wastage due to eddy current effects.